Hello everyone. Today we are going to talk on the status and emerging trends in Indonesian shrimp farming. It was presented on June 22nd in AQUA India 2022, organized by SAP, Society of Aquaculture Professionals in Chennai. So agenda is present the status of Indonesian shrimp farming, challenges, new normal, standard operational procedure, CPP concept and perspectives, and take-home message. Present the status of Indonesian shrimp farming. Indonesia is one of the leading countries in the shrimp farming. What we see, the culture conditions that Indonesian shrimp farming can be divided into three major farming levels. First one is intensive, which covering about 9,000 hectare of area. Productivity is 30 ton per hectare, and in biomass it turns around 271,000 metric ton. Semi-intensive, which is covering about 43.6 thousand hectare of area. Productivity per ton is about 10. Biomass is 436,000 ton. Extensive, which is the highest, 247.8 thousand hectare area. Productivity is the lowest, 0.6 ton per hectare, and it provides about 148.6 thousand ton of shrimp. So total, it goes about 300,000 hectare of area. What are the challenges? We look at this graphics. Disease is considered as one of the major problems to aquaculture production globally, with $6 billion loss annually worldwide. If you look at, almost 55% of the loss is due to bacterial diseases. Virus comes second, about 22.6%. Parasitic diseases are 19.4%, and then fungus. When we talk about the emerging diseases, whitefish syndrome, white gut, EHP, these all are so far considered as the causative factors. You can see these are the fishes floating on the water, and because of that, you can see the high size variation in a population from the smallest to the highest. This is how the gut and hepatopancreas looks like, all whitish. And here you see the healthy or normal shrimp. When we take out the gut, you can see it's the white colored, and this one is the normal brown or dark brown colored. We had several trials in the lab to optimize and to study how the white fishes is and how is the disease transmission goes. So in this, when we challenge them artificially in our DG challenge lab, what we saw, there was a high size variation. You can see the upper image is control, which is almost same size, but at the lower side you can see the shrimp with the lowest size to the highest size, or it is the minimum is about 3.49 gram, and the biggest one is about 11.2. Sorry, this one is 14.47, and this one is 0.5, and the normal one is 3.49 to 11.29. This is electron microscopic image, negative control. You can see the hepatopancreas tubules are normal and very good looking and consistent. But here you can see how the damage is done, and no tubules are visible, and it's hard to recover for these damaged tubules. The second one is IMNV, infectious myonecrosis virus, which is very prominent in Indonesia since 2009-10. This is how it looks like. The tail is very beautiful. If you look at, there is no problem with the growth, no problem with the feeding, unless and until shrimp get stress. When it gets stress, then you can see there is heavy mortality. The last image, you can see when the The last segment is broken, damaged, but the gut is still full and shrimp keep on eating. So new normal SOP. So our company, Central Processing Prima, worked on the development of modification and improvement on the techniques and which help to fight against these diseases with the concept living with the virus. So for sustainable development, we have 5 steps. First is concept and new normal standard operational procedure. Second, prevention of pathogenic entry in the culture environment. Third, good management practice. Fourth, technology development to minimize the risk. Fifth, creating awareness. So what are the open secret of shrimp farming? Like the ponds are smaller sized, 1,000 to 3,000 meters square. We reduce the size of ponds, which helps us to manage them in a better way. Semi-flock system or bacterial system. So we reduce the dependency from the plankton system, which are more fluctuative and give higher stress to the shrimp. Siphoning, starting from 14 day of culture, siphoning is cleaning the pond. So the high vibrio load or even stress the shrimp is caused when the organic load at the bottom increases. So we by doing the pond bottom cleaning, we reduce the organic load from the bottom. Automatic feeder started introduced and using high water exchange. We go up to 900% water exchange. Calcium and magnesium ratio has to be maintained up to 1:3. Partial harvest has become part and parcel of Indonesian shrimp farming. Understanding and maintaining the carrying capacity. We must understand what is the capacity of our farm, how old it is, and how to provide it extra support. Continuous production is key because of the weather. Value-added products improvement. Indonesia is having almost 30% of the domestic market, which consumes shrimp produce. Biosecurity, real-time PCR introduced, and now all the hatcheries are well equipped with real-time PCR machine. PL type stocking as per the problematic area, whether it is red zone, so the resistant PL will be introduced. If it is a green area, then fast growth shrimp will be introduced there. Reservoir, continuous monitoring of culture and surrounding area. This is the new normal SOP. 10 points. So improvement on farm layout to improve biosecurity, preparation of farming area and water based on the standards, apply AquaGuard for pond bottom disinfection, the use of high quality fry which frees from AHPND, WSSV, EHP, IMNV and other pathogens. Reduce the stocking density, good management of water quality and feed, the use of real-time PCR to detect HPND, WSSV, EHP, and IMNV, socialization of AHPND, WSSV, EHP, IMNV prevention to all the staffs and partners, increase biosecurity management, maintain the dissolved oxygen level above 4.5 ppm, and maintain the Vibrio count low. OneGuard application as an immunomodulator. If I just describe the critical points, old SOP and new normal SOP. So layout, before sedimentation pond was about 8%, treatment pond 22%, and culture pond 70%. Now sedimentation pond is about 8%, treatment pond 17%, reconditioning pond 8%, and culture pond remains 67% only. Stocking density, before 134 pieces per meter square, now it is 120 pieces per meter square. Water exchange rate per cycle 800%, 900%. Pond bottom cleaning, before was starting from the second month of culture, now from the second week. Disease surveillance was relaxed, now tightened. Dissolved oxygen level was more than 4 ppm. Now it's more than 5 ppm, or 4.5 ppm is the threshold level. Culture system, balancing the number of plankton and bacteria. Now balancing the number of plankton and bacteria, keeping the plankton number stable. Pond guard, previously no pond guard was applied. Now pond guard application is done. Pond preparation, use lime, calcium oxide around 1 ton per hectare. Now it is 1.5 to 2 ton per hectare. This is mainly to deactivate the EHP spores. Biosecurity, PCR-based monitoring. Now it's real-time PCR. Monitoring is done 2 times a week, and total organic matter should be less than 100 ppm. When it comes to Vibrio, when it is checked on TCBS agar, then green Vibrio should be less than 100 CFU per ml, and yellow should be less than 1000 CFU per ml. Come to the natural products, popularity in Indonesia. Almost 45% of the farmers in Java province are using one or the other products which are having natural origin. And what we can see the worldwide in case of publications, that it has keep on increasing, means the demand and the importance of natural products, herbal products are getting importance in universities and in scientific communities also. So we can see the peer-reviewed journals are publishing more and more publications related to natural and essential oil supplement. We have new technologies like in silico talking methods, from which we can see and prove that how this active ingredient from the natural component can deactivate or bound to the viral and bacterial components. Then come to the enhancement of biosecurity, especially in the hatchery. We use a spraying method to deactivate the viral and bacterial pathogen, which are carried by aerosol transmission. You can see it is sprayed all over to deactivate the Vibrio and other pathogens which are attached to the wall, roof, or containers in the farming area. Then brooder stock and live feed management, all this, whether it is polychaete, algae, diatoms, artemia, all should be produced in a biosecured facility so that they should not carry any pathogen. Post-larvae production should be done in a well biosecured, pathogen-free area and stress-free environment. Packaging is also part. Packaging and transportation should be done in a way that PL should have less stress, and then transportation should be done in a cool truck so that there should not be much fluctuation in the temperature during transportation. Then good management practice at farm. Follow standard operational procedure, measure to prevent pathogen entry, and keep the pond environment clean as your home. Shrimp cultivation business process. From the perspectives of aquaculture practitioners, disease arise due to management problems or mismanagement. This in terms of implementing the principles of best aquaculture practices in a series of shrimp farming activities. And come to management. Water sources for cultivation and treatment of water before it is used for cultivation. Land preparation according to the type, construction of pond layout, how to grow plankton, feed management, use of probiotics, bacterial culture, management of pond bottom organic matter. Pond construction, pond bottom drying, then pond bottom cleaning and installation of pond equipment. Then step 4 is liming and installation of biosecurity device. 5th is water intake after water comes in. then sterilization of water. Then go to point number 7 is plankton growth. But now we don't apply any specific fertilizer so we don't encourage plankton to grow. Whatever it grows naturally is okay. Then fry quality checking, then fry stocking, shrimp culture. During culture, go for water management, sampling, pond bottom management, and disease monitoring, harvest and for post-harvest management. Just want to show you the ideal farm where water is taken from the sea. This is open sea, and this is the main inlet where water flows. And this green one is the outlet water where dirty water comes out and dirty water is drained into the river. These are the units of culture ponds, culture area. These are the reservoir where water is taken from the inlet, then disinfected, and then supplied to the culture pond area. This is a smaller unit, you can say main inlet, where water is coming from the sea. And from here it comes, this is the whole unit is called reservoir as a whole. And then it is subdivided into quarantine pond, sediment pond, treatment pond, and then a reconditioning pond. From reconditioning pond, it is supplied to the culture ponds through sub-inlet. And then from here, we call supply canal for one module, where water is supplied to each pond. Then the dirty water from central drainage is flushed to the sub-outlet, and from sub-outlet, it goes to the main outlet and then to the river drainage. This is the central drainage area. See, so this is sun drying after post-harvest. Then pond bottom is cleaned before intake of water. All the repairing work is done. Then equipment are installed. Sometimes we do liming by taking off the HDP lining. Then these are the filters. Then bird escape device, crab protection device, this water filtration. This is vehicle wash at the entrance, disinfection, and foot bath, hand wash, and barrier beside paddle wheels to protect, through the aerosol, which could be carrying some agents. Now, shrimp culture system. When we talk about bacterial culture system, it is the concept of the system is nutrient balancing. That refers to the carbon, nitrogen, phosphorus ratio to promote nitrification process in the shrimp culture. Second, the target is to reduce the stress factors by providing the stable water quality parameters in the pond system. Third, common stress factors considered are blue-green algae bloom, plankton drop, bottom waste, high total ammonia nitrogen, tan, nitrate, and high count of vibrios and other pathogen. So total organic matter generally comes from either from the water intake or from the accumulated organic matter in the culture pond. Number 4, various probiotics and nutrients at different stages of culture are inoculated to maintain the balance in the system. 5 and 6, a fermentation process is one of the important steps, which is done. Partial harvesting is done several times to maintain the carrying capacity of the pond. And step 7 is lining of ponds to provide the darker color of shrimp, which has higher value in the export market. Fermentation process for bacteria growth. Application during water preparation, grow phytoplankton. Uses of mixture of rice bran, 1 ppm, and yeast 15 gram per kg of rice bran. Dolomite about 5 ppm should be mixed before application. Application during culture is uses of solution of rice bran or soybean meal, 1 ppm, and yeast 15 gram per kg of rice bran, and molasses 0.1 to 1 ppm. Dolomite about 5 ppm should be mixed before application. Application of nitrifying bacteria 0.2 to 0.5 ppm. And this here in the table, we have tried to describe the difference between bacterial system and plankton system. It comes to pH, bacterial system 7.3 to 8.3, plankton system goes 8 to 9.5. Alkalinity 110 to 170, 120 to 250 ppm. Total bacterial count up to log 4. Total bacterial count 100 to 10 to 100 times of total Vibrio count. And that the total Vibrio count should be less than log 3, should be more than log 3. Plankton should be in log 5 to log 6 ratio. And one, say if we just like to observe, then we can see the difference in the splashing water by the paddle wheel. If it is a bacterial system, you can see it's a white colored, whereas in the plankton system, you can see it has a greenish tinge. PL stocking, upon the shrimp, PL arrived, they were checked. So you can see it's all in the cooling truck. Quality checked, stress test is done, then acclimation will be performed, and then PL will be released. A certificate is produced by the hatchery from the quality control department. So this is the monitoring of health. So shrimp activity and condition, like visual using feed tray and central feed tray, cast net sampling is done daily. Shrimp growth and condition, weekly sampling, real-time PCR, weekly, hepatopancreas monitoring, weekly. Then sampling is 6 days before stocking, water and mud, 1 day after stocking of post-larvae, shrimp, water and mud. So first week, then second, third, weekly basis, shrimp and mud are checked. Shrimp health monitoring, hepatopancreas observation should be normal, hemolymph, clotting. Faster the clotting time, healthier the shrimp. Plankton monitoring is done on daily basis. Then feed tray monitoring, normal observation, farmer or technician just sit on the dike of pond and observe the shrimp and water, and health examination. This is semi-flock system, how the water color looks like. Now, culture pond. What is the role of a good technician and a bad technician? If we talk in that way, we have to look at a pond system where at the time of PL stocking, the water was carrying some level of white spot syndrome virus. So the same water was, supplied to 2 ponds. One pond was maintained by a good technician, and the second one had poor management. And what we saw, poor management pond got stressful condition, and disease was able to appear because that stressful condition gave ample chance to the virus to multiply and come to the minimum infectious level. And so shrimp could get infection and die. But in case of good management pond, the virus was not able to replicate in the certain quantity, and at the end, a technician could have the normal harvest. So pond is the home of shrimp and water is the environment. Dirty home and dirty environment will make the shrimp sick. The culture water can be cleaned in many ways. The most important is to have reservoir. Reservoir plays role of boundary and creates buffer zone between the culture area and the open environment. So the water, when it is coming from the sea, reservoir is the one which is making the sanitation of water, making the water more cleaner and adaptive, and then enters to the culture pond. Ways to maintain the healthy environment is pond infrastructure. Time to time, we have to check and improve the infrastructure of the pond. increase the dissolved oxygen level. As we have seen, from 4, we have now put our level to 4.5, should be the minimum DO. Feed efficiency, we have to use automatic feeder or increase the frequency of feed application. And then go for partial harvest to maintain the carrying capacity and reduce the load. Now come to probiotics. Probiotics or friendly bacteria act in the ways of competitive exclusion. So to make and maintain that, we have to make sure that there is a enough ratio between good bacteria and bad bacteria. Good bacteria, if we consider probiotics, if it is it should be 100 times higher than the bad bacteria. Why? Because good bacteria grows slower. Take bacillus, it multiplies in every 6 hours, whereas bad bacteria, if we take example of Vibrio, it multiplies in every 20 minutes. So bad bacteria grow 18 times faster than the good bacteria. So probiotics is never the remedy for bacterial diseases, but it's a tool to be competitive exclusion. So to be competitive, we have to be in certain number. Then second concept we use is mixed farming. Tilapia is one of the favorite candidates, which helps to reduce the vibrio load and also infectious myonecrosis virus reduction. This is to maintain healthy environment. We also focus on low organic water system. This system focuses on reducing the organic load in water. Raw water is kept in a sedimentation pond and treated with chemicals to reduce the organic load in water. The water is filtered at every step. The ratio of reservoir pond area to culture pond is about 70 to 30. If we take, example of conventional less water exchange and organic and low organic load culture systems, then size of pond in hectare 0.64 to 0.96 hectare, low water exchange 0.96 to 1.6 hectare, and 0.32 to 0.64 hectare. Depth 1 to 1.2. Here is 1.5 to 2.5. Here is 1.5 to 2. Water volume is accordingly. Stocking density is lowest here, 20 to 40 pieces per meter square. Here is 60 to 120. Here is 120 to 320 pieces per meter square. Pedal wheel aerator accordingly, 6 to 12 horsepower per hectare, 12 to 24 horsepower per hectare, and 24 to 63 horsepower per hectare. Organic waste management, kept in center of pond, water exchange. Here, kept in pond center, siphoning on top of water, decomposed by bacteria, siphon organic waste, high water exchange, and recycling of water. Environment, clean water, no decrease, disease, virus, disease, bacteria. What are the strengths? Low energy consumption, receive oxygen from plankton and water exchange. The strength of less water exchange is less water consumption, receive oxygen from plankton. Low organic load benefits are or strengths. Low organic load, high stocking density and increased productivity, reduce the risk of disease from bacteria, reduces organic waste released into the environment. What are the weakness of conventional type? High water consumption, around 5 to 10 times culture pond volume, risk of disease infection, release water to environment. For the less water exchange culture system, high energy consumption, poor water quality, shrimp stress, risk of bacterial infection. The low organic load, high water consumption, high energy consumption, need large area for water treatment, need to redesign farm. Post-harvest parameters. It includes 2 to 3 times partial harvest, final harvest. Partial harvest means harvesting or taking a portion of shrimp from pond at a certain time and continuing the shrimp culture until the final harvesting. The freshness and color of shrimp are important parameters. The other parameters also measured to calculate shrimp production. These are the steps. Post-harvesting, where temperature maintenance to 2 to 5 degrees is very important, which retains the original color, and better the color, higher the selling price. Take-home message: healthy PL stocking in well-prepared pond and water guarantees over 70% success. Adaptive farming technology: any techniques is developed based on the local issues and infrastructure. It should be adopted and modified as per the conditions. Post-harvest technique development: greed is the most lethal disease. We must get rid of the greed. We had reunion after COVID. All the friends, elders, we could able to meet, discuss. I would like to special thanks to SAP management, especially Dr. Victor Suresh, Ravi Alanki, for inviting and giving a space to talk. Then Dr. Romi for providing some government-related data, Mr. Dilip Satyanathan to help me to get details about the Indonesian shrimp farming. Then our Central Protein Prima Management, RIA Management, and Kunki, Kunsarai, Christina for providing assistance on data and knowledge. Combination of everything, I'm able to talk to you. Thank you very much.